So reading that top part should be a review. And then getting to the bottom part there. When you got down to the bottom there, it started talking about one of the functions you've already graphed and you've already dealt with an equation for. Which one is that?
H minus
Yeah.
x.
The quantity of h minus x squared plus quantity of y minus k squared equals r squared.
Okay, good. So that's the equation for a
Center of a circle.
circle. Okay, so we have our equation for a circle. That's the one we won't go through in here, but you spend a lot of time with it in geometry. Okay, that chapter 12 when we did it. So if you turn the page, take a look at the next page, start talking about parabolas, and today that's going to be our focus. We're going to go into parabolas. Now, understand that when you start talking about conic sections, they're referenced as quadratic relations. Okay, it's because to get those conic sections you use quadratics. Okay, it's not just the parabola, but you've seen this form before. F of x equals ax squared plus bx plus c. Okay? The definition of a parabola, this is the actual definition. So of everything you know, you're like, yeah, it's the U-shaped graph, or it's the happy face, or whatever. There are actual properties of a parabola. These are the properties. So I want you to read through the properties of a parabola in standard form or standard equation for a parabola there. Okay? And we'll go through some examples. Of a parabola. Parabola is a set of all points x, y in a plane that are equidistant from a fixed point or a fixed line called the
Directrix.
Good. It's called the directrix. Okay? And a fixed point called the focus, also referred to as a foci. Okay? All right. I know. Pretty cool. Or foci, foci. Okay? So right here we have this point. That's our focus or our foci, and then we have our directrix. Note that this length, if you intersect the parabola at a right angle, that length is equal to that length. Those two lengths are the same. Or if you pick a point here, as it goes down to the directrix at a right angle, that length is equal to that length. Or if I picked another point, that length at a right angle would be equal to that length. Everyone with me there?
Yes.
That's what makes a parabola a parabola. All right, and we'll see a picture of how that can be applied in kind of your everyday use. But that's what makes a parabola a parabola. So any little U shape is not a parabola. Okay? So, standard form. You guys are used to seeing standard form of a parabola as being y equals ax squared plus bx plus c, right?
Yeah.
Well, notice when they go into standard form here, they get x squared alone. They say the standard form of an equation of a parabola with vertex at 0, 0 and the directrix at y equaling negative p. That means if we go back to this picture here, they're talking about negative p. They're talking about if this is 0, 0, this is p units from the 0 or from 0. You go down p. Okay? Or they kind of show that as well right here. Y equals negative p. That's the directrix. Notice the directrix and the focus are the same distance from the vertex. They're equidistant. How many are with me right now? Okay. Very good. Well, they go through and they say, well, I'm not going to have x squared with that a. I'm going to move a to the other side. How do we move a to the other side?
Divide by
Now, some of you are looking at it saying, I don't even see an a here. I don't know what he's talking about. Stay with me here. How do we move a to the other side?
divide by a.
Divide by a, so you get y over a. Okay, rather than writing it as y over a, I'm going to write it as y times
1 over a.
1 over a. Now, they're not using 1 over a. What are they using?
E.
They're using
4p.
4p. Everyone see that? So instead of calling it 1 over a, they're calling it 4p times y. The only reason I point that out is because 4p and 1 over a are the same thing. And the reason why I point that out is because when we talked about it in class, when we knew what a was, how many remember graphing a parabola? Remember you graph, you'd say I plot my vertex and then I go over 1 and up.
1.
Not necessarily 1.
Well, over 1 of A.
Over 1 up a. That gave me my first point. Everyone remember that?
Yeah.
Okay. Well, so it's nice to know what a is. A, 1 over a is 4p. Okay, because the equations we come up today, we're going to put in this form. 4 times p times y equals x squared. Why use p? Because p is this length. It tells us this distance. So it's nice to know what the p value is. Okay? So if I gave you an equation with an a value, you should be able to figure out p. Right? Okay. So that's going to be our goal. So we're going to focus in on these two equations. X squared equals 4py. Notice p can't be 0, otherwise x squared just equals 0. Okay? And y squared equals 4px. Now notice this is x squared. That has a vertical axis of symmetry. This is y squared. It has a horizontal axis of symmetry. This is a function. Is this a function?
No.
No. Doesn't pass the vertical line test. However, we're going to refer to those. Okay. How many are with me? Okay, any questions so far? All right. I want you to take a look at example 1 on the next page. Turn that over. Read through example 1 there. Once you finish example 1, I want you to try this little checkpoint right here and put it in your notes. All right. Hey, questions on the example, maybe not the problem, but just reading through. Like, I got lost where they did this. I have no idea what they meant here. Yeah? Right here?
Yeah.
So how they got from here to here? Okay. Did anyone get lost before that? We'll come back to that. How many were able to follow along till right here? How many got lost right here? Okay. This represents this negative 1/2. If you think back to your equation, x squared equals 4py. That negative 1/2 represents what part of that? 4p. So you know negative 1/2 equals 4p. We want to find p. How do we find p? You can divide it by 4, right? So dividing by 4 is the same thing as multiplying by 1/4. Okay, multiplying by the reciprocal of 4. So the other way to think about it, if you have negative 1/2 divided by 4 over 1, that's the same thing. Getting really small there. There we go. That's the same thing as multiplying by, all right, same thing as multiplying by 4, so we can think of that as negative 1/2 times, or excuse me, multiplying by 1/4, by like that. So we get our negative 1/8 right there. That's how they got negative 1/8. So they're saying p equals negative 1/8, and they're putting that into this equation to write it as x squared equals 4 times p, or negative 1/8 y. Good question. Oops. Okay. Any other questions on it? All right, everyone understands why it opens downward.
Yeah.
I would just look at it and say it's negative 2. I mean, that opens down. Okay. All right. Let's try this one. Find the focus of the parabola whose equation is y squared equals 2x. Okay, how many have done that? All right, so if we got y squared equals 2x, we want to go into the form of y squared equals 4p times x. And 4p in this case equals 2. Right? So you get y squared equals, You have 4p equals 2, so p is 1/2. So 4 times 1/2 x. What does that tell us? What does p tell us?
Where the focus is.
Look back to your notes. What does p tell us? There's our vertex that's centered at the origin. Okay, there were 2 other points that we added today. One is up here, or down here, I guess, or over here. Here. What are the 2 points that we had? One's called
The directrix.
the directrix. That's actually a line, and the other one, the focus. Okay, and so as Andrew said, the 1/2 tells us how far from the vertex those 2 points are. So in this case, this is a y equals graph. It opens this way or that way. That's what we know. If it's y equals, if it's, or y squared equals. If it was x squared, we know it opens up. If it's a y squared, it opens this way or this way. This is telling us it's 1/2 units. Okay? It's going to open this way. All right? It's a positive amount. The other way to think about it is a is positive. Okay? Or 4p is positive. Okay? It's opening this way. My focus would actually be at this point right there. And my directrix would be out here. Okay, so this would be my focus. It would be 1/2. That would be at the ordered pair 1/2, 0. And my focus would be at the ordered pair -1/2, 0. And my graph would open this way. Would this be a wide or a narrow graph in comparison to a parent function?
Would be narrow or wide.
Talk about it with your group. Would this be wide or narrow compared to a parent function?
Be wide.
How many say wide? How many say narrow? How many are guessing? Okay, that's all right. So think of it this way. This is y squared. What determines our width? What variable?
A.
Our a term does. So this is y squared. We're kind of extending this problem. It didn't ask for all this, but if I have y squared equals 2x, and I move this 2 back over here, what is it now? How do I move 2 over? Divide by 2 or multiply by?
1/2.
1/2. 1/2 y squared equals x. Okay? If that's the case, does the 1/2 make it narrower than the parent or wider? Wider. Okay, this is wider than the parent function. Remember that it's like a speed limit. The smaller it is, the slower it's going up. The bigger it is, the faster it's going up. Okay? All right. With that being said, all they wanted you to do in this whole problem was find this. Okay? Trying to explain the rest of it there. Okay, what I'd like you to do right now, I want you to go ahead and turn to page B9. B9. And in the next, using the next 7-8 minutes, I want you to work on these problems right here. 9 through 16. Hey, okay, so since you guys started number 9, let's try it together here. Y equals 4x squared. It says find the vertex and the focus of the parabola. What's the vertex?
0,
0,
0.
0. It's like, why are they even asking us that? Okay, that's the vertex. The focus. Well, the focus is, think back to your graph. So this is a y equals 4x squared. This graph, which it tells you to sketch, this graph does this thing. We're here, and it's a 4. That means it's going up fairly fast relative to the parent function. It does that. That's not a great parabola, but we're going to go with it. Okay? We've got that, and our focus is right here. Okay? We're trying to find the coordinates of that point, which means in order to do that, we need to find what value?
P.
We We need to find p. Okay? So we know the equation x squared is equal to, what's the equation? 4py. Okay? And right now, x squared's alone, so we should really probably get x squared alone. So move that 4 over to the other side to get x squared equals.
1/4y.
Multiply by the reciprocal. 1/4 y. Okay? So 4p equals
1/16.
4p equals 1/4.
Oh, yeah, 4p equals.
So if we have 4py, or 4p equals 1/4, divide both sides by 4, we get p equals 1/16. So we can rewrite that as 4 times 1/16 y equals x squared. The 1/16 tells us that point right there. So what are the coordinates of the focus?
0, 1/16.
Good. The focus is 0, 1/16. Got that. We got that. And we got that. Questions on what we did there?
Oh, sorry.
How many had that before I came up here? Didn't draw the graph. You got to sketch the graph, man. It's a sketch here. I know. All right. Very good. Keep working. Okay, so we're looking at B3.
That's B15.
Hey, on B3, I want you to look through example 2, read that, and then try checkpoint number 2 in your notes there. Okay? Any questions on example 2? Okay. Checkpoint 2 is the right standard form of an equation with a parabola at the vertex at the origin and a focus at 0, 2. Who has the equation there? What you got? Yeah?
I don't know if it's right, but I was thinking since it's y squared equals 8x and the thing's at 2, 0, so if it's at 0, 2, it would be x squared equals 8y.
Okay, so since it's at 0, 2, it has to be an x squared. So if you think of your picture right away, if the focus is at 0, 2, that means right there, centered at the origin. Okay, if the focus is there, that means our graph is opening upward. So that's an x squared graph. So x squared equals 4px. And what did you think it was?
X squared equals 8y because p is 2.
Good, yeah, p is 2. The focus is at 0, 2. That means this length right here is 4. Or excuse me, is 2. Okay? So that gives us x squared equals, thank you, that should be y.
Lol.
Unbelievable. Nice job. How many got that? Good.
I would have done it.
Okay. Hey, I want you to take a look at this bottom part here. It says parabolas occur in a wide variety of applications. One that you can maybe relate to a little more is a parabolic reflector can be formed by revolving a parabola about its axis, resulting in the surface that has property of all incoming rays parallel to the axis are reflected through the focus of the parabola. Okay, this is what we use when we're dealing with reflecting telescopes. Use the same kind of idea when you're dealing with flashlights. How many of you have used your phone as a flashlight before? Okay, and then a flashlight as a flashlight. Okay, a lot of times the flashlight works a lot better because the rays are actually focused at a specific point. Especially if you're not using the, some of you have you have the little app that it's the assist to light and stuff, so it gets really, really ultra bright. Okay, some of you just take your phone and you're like, you turn it on and you're like, going around trying to figure things out. Okay, you're like, man, it has so much light, why can't I see? Because the light isn't focused. In a flashlight, the rays are actually focused so that they're all pointing in a single direction. They're not just like random. Think of it this way. It's like you waking up in the morning. Guys, most of you, I'm sure girls can relate too, but I don't relate as much anymore because my hair is a little shorter. But guys, you wake up in the morning, your hair's like, whoom, okay? And then you focus it, most of you. Some of you don't focus it. Some of you just go to school, okay? All right.
I have to, otherwise
All right. Didn't mean to get us off task with hair, but
this is morning.
moving on.
Good morning.
Everyone go back to B9, please. B9. B9.
That was clever.
Stay with me. Everyone's attention right here. If you are talking, be done. Okay, so we are going to complete 17 through 26 now. Okay, so 17 starts here. 26, you have to turn to B10 to 26. Okay? That's what we're doing. And that's it for today. Yeah, okay, let's talk about 15 real quick. So the previous section. Number 15. So on number 15, if you're doing that one, you have to get y squared by itself, right? So we'll subtract that x over. So we get y squared is equal to negative x. Okay?
Okay, yeah, I got it.
And so then 4p equals negative 1. So p is negative 1/4. So y squared equals 4 times negative 1/4 x, which means if p is negative and you're doing a y squared graph, that graph is going to open this direction, the other direction, the evil twin of one direction. Okay? So that way you're opening that way. You have your negative 1/4. So your focus is at negative 1/4, 0. Okay? Which means this negative 1/4 actually carries through. It should be a negative 4. Okay? And vertex is 0, 0. All right. There you got it. That's what you're doing for today's stuff.